So good morning, welcome to Sakala Vidya YouTube channel. So we have been discussing the problems on probability. So that's also multiple choice questions which will be useful for National Talent Search examination as well as even for Andhra Pradesh or GUCET examination or for some other competitive entrance examinations. So in the last session we had up to 23rd problems we have discussed. So in this session at least we try to complete 20 or 21, 22 problems. We shall complete it. So in the evening session we have one more session is there, coordinate geometry. So that's very important chapter. Even beside the probability, the coordinate geometry also very important for the competitive entrance point of view. So today now in this session, so let us complete few problems on probability. So we shall try to complete the chapter in this session itself only. So tomorrow we shall have the one more session. So on this a particular entrance point of view, RGU entrance point of view questions will be discussed. And moreover, and regular SSC, that means 10th class Andhra Pradesh and Telangana, so will be started day after tomorrow onwards. So welcome Pavitra and Sekhar, Abhiram Sekhar. Welcome all of you. Okay, let us start the 24th problem. Fine. I am fine, very fine. What about you people? Okay. So all of you like, subscribe and share. So you need to continue till the end of our session. Okay. Am I audible? I think. If any problem you can chart. So 24th problem. A digit is randomly taken from a logarithmic table. The probability that the digit is, that means selected digit, the digit is either 0 or 9 is. This is the question. Good morning, Akula Vijay. Welcome. So first option, sorry, that means A, option A. Say option A is 2 upon 5. Option B 1 upon 5. Option C 3 upon 5. Option D is 4 upon 5. Okay, let me read the question once again. A digit is randomly taken or selected from a logarithmic table. So that means first of all, so we need to write n of s. How many digits are there? So generally we have the digits from 0 to 9. So the total number of digits you will be knowing. That is actually 10. N of s is 10. And now we need to select out of them either 0 or 9. That means only two cases, either 0 or 9. N of E or N of A is 2. So the required probability, we know the formula, P of E is equal to N of E by N of S, so that we can find out. The answer is 2 by 5. Obviously, A is the right answer. So let us proceed for the solution now. So let us write here N of S being 10, because yes, so the digits are from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n of s is equal to 9. Out of them, we need to select either 0 or 2, means 0 and 9. That means if you say the required event is E, n of E is equal to C, 0, 9, two cases. So now the required probability P of E is equal to, as for classical definition of the probability, we can write n of E. So number of favorable cases to happen the event A upon total number of outcomes. So that is 2 upon 10. So to 1 ja to 5 ja. So 1 upon 5 will be the right answer. So that means option B is the right option. So you can check it. Good morning, Uday Kumar. So welcome all of you. So shall I move to the 25th problem? So let us move together towards to the 25th problem. I hope you have understood this 24th question. So 25th problem. So let's have a discussion on 25th problem. So it will be somewhat a very different problem and also very beautiful problem. A dice. Generally, the dice may be used for singular as well as the plural. Some textbooks it may be die given, but even one dice also we can say no problem. A dice is in the shape of a tetrahedron as shown in the figure. On each face, the description is given. On face, one of the numbers one of the numbers 1, 2, 3 or 4 is written, is mentioned, that means is written. The probability of getting a prime number it's very easy. Just understand the problem, that's enough. Just if you are able to analyze the problem. Abdul Rahman, good morning. So let me give the figure, tetrahedron figure. Is a three-dimensional figure. So like this we get, this is a tetrahedron. So let us, vertices you say, no problem, you need not write vertices. Numbers on each face, first face, second face and third, and below also fourth face downwards. 4 faces it has. So number like this 1, 2, 3, 4. So out of this 1, 2, 3, 4, if one of the number has been selected, it must be a prime number. That's, see, a dice is in the shape of a tetrahedron. So as shown in the figure, on face the 1, 2, 3, 4 has been written. The probability of getting a prime number. Prime number means what are the prime numbers? You check it. 2 is even prime number and 3. 2 cases are there out of 4 cases. Obviously 2 by 4 is the answer. So let us write the options also. So before going to attempt our problem, see, this is 1 upon 2. B is 1 upon 3. C is 1. D 0. So good morning. So now the solution follows. N of s n of s is equal to, as it has 4 faces, the first face is numbered with 1, second face 2, third face is 4, fourth face is 4. So n of s is 4, where e be the event of getting a prime number. How many prime numbers are there? 2 prime numbers. So n of e is 2, obviously. Very good. Kavali, yes. P of e equals to n of e upon n of s, so that we get 2 upon 4. Okay, you are correct. So good morning. 2 1 ja, 2 2 ja. So that is 1 upon 2. That means obviously A will be the right option. Okay, am I correct? So now let me move to the 26th problem. 26th problem. So problem number 26th. 26th problem. Yes, Nana, it's correct. A number x is chosen means selected, chosen at random from so -4, -3 negative numbers, -2 or -1, 2, -1, we can say like that also, 0, 1, 2, 3, 4. The probability that the probability that welcome mod x less than or equal to 4 is option A is 0, option B is 1, option C 1 upon 2, option D 1 upon 9. 1 upon 9. So Vaishnavi Rati Devi, welcome. A number x has been selected at random from the numbers -4, -3, -2, -1, 0, 1, 2, 3, 4. Total how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 9, so one number has been selected, that is x selected. So it must be mod x less than or equal to 4. First, let us have a discussion what is meant by mod x less than or equal to 4. So let me give that concept here. The concept, so first we need to discuss the concept of mod x is less than or equal to a, where a is positive number greater than 0. This means that x lies between negative a and positive a. Minus a less than or equal to x, x less than or equal to a. So that means as for this condition here, we can write -4 less than or equal to x, x less than or equal to 4. So that means we need to select a number in between -4 to 4. How many such numbers are there? -4, -3, -2, -1, 0, 1, 2, 3, 4. So okay, let us write it now. Okay, Kutumbrao, welcome. So now, so first directly let us write n of s. That can be written. You count the total numbers we given. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let E be the required event. So that must be in between this interval. -4 is included. -4, -3, and next -2 and -1, 0, 1, 2, 3, 4. So that means actually n of e is equal to 9. That means it is going to become a sure event. Yes, absolutely correct. P of e equals to n of e upon n of s. So that we can write 9 upon 9 whose value is 1. So B is the right option. B is the right option. Yes, yes. So 27th question. A child has a block in the shape of a cube with one letter written on each face as follows. So in general the cube has the 6 faces and each face one letter has been written. So as follows. So like this is the first face, second face, third face, fourth face, fifth face, sixth face. So on which the letters written like this: A, B, C, D, E, again A. Okay, let us come to the question part now. The cube is rolled at a time, rolled at once or at a time. The probability that the probability that the letter on the face is A. Option A 1 upon 3, option B 1 upon 6, option C 1 upon 2, option D 1 upon 4, option C 1 upon 4. Shall you try this question? Okay. Okay. So let us do it now. Solution. First, let us write n of s. N of s means, so even it is repeated, you need to consider as a so two different objects. 1, 2, 3, 4, 5, 6 faces. N of s is equal to 6. N of e is equal to, the letter must be A. How many? 1, 2 chances. So n of e is equal to 2. So obviously the probability P of e is equal to n of e upon n of s. So that you can visualize in your mind itself only the answer. 2 upon 6, that will be 1 upon 3. 2 1 ja, 2 3 ja. A is the right answer. Yes, Anjaneyulu Pitala. Absolutely correct. Lasya. So 28th question. 28. Cards each marked with one of the numbers 4, 5, 6, so on 20 are placed in a box and mixed thoroughly. One card is drawn at random from the box. The probability that so 1 minute, let me continue. Okay. Cards each marked with one of the numbers 4, 5, 6 up to 20 are placed in a box and mixed thoroughly. One card is drawn at random from the box. The probability of getting an even prime number. Good morning, Bhavani. An even prime number. A. So good morning, Baji. A. 0. B. It's very interesting question. Just logic is there. C. -1. D. 1/2. Nagesh. Pavitra. Cards each marked with one of the numbers 4 to 20. 4 to 20 means n of s. Let us find out first of all. But answer is 0 obviously, because there is no even prime number means only 2, but 2 is not present in this one. That's why it is impossible. Impossible event means obviously 0 itself only, but let us write it. So this, how many numbers are there? 20, subtract minus 4 and add 1. 17 are there. So n of e. N of e means there is no even prime number 2. That's why 0. So P of A is equal to, directly we can write 0 upon 17 is 0. So this is an impossible event. Twenty-nine. A letter is chosen. A letter is chosen from the word A, P, okay, N, A, Aparna. The probability of choosing A is A 1 upon 5, B 2 upon 5, C 1 upon 2, D 3 upon 5. 3 upon 5. Yes, even prime number is only 1. A letter is chosen from the word Aparna. How many letters are there? 1, 2, 3, 4, 5, 6. Out of 6. So the probability of selecting A or choosing A, how many A's are there? 1, 2, 3. 3 upon 6. Obviously C is the answer. Right. So now let us come to the solution part. First let us write n of s. Count the number of letters are present in the word Aparna. How many number of there? You need to treat them each is different objects itself only. There are 6. N of E. N of E is equal to A's. How many A's are there? 3A. 3A. Not S is A. Letter A. So P of E. P of E equals to N of E upon N of S. This is the formula. So 3 upon 6. That is 1 upon 2. Yes, C is the right option. Thirty. A letter is chosen at random from the English alphabet. The probability that the letter chosen is a vowel. Is a vowel. Is a vowel. You try this question, all of you. A. 1 upon 26. B. 3 upon 26. C. 5 upon 26. D. 1 upon 52. 1 upon 52. See, a letter is chosen at random from English alphabet. The probability that the letter chosen is a vowel. It must be vowel. English alphabet. So welcome electronics for you. How are you? Yes, welcome. Mokshit Reddy. Welcome Mokshit Reddy. Right. Oh, long back. Right, no problem. But so due to some another circumstances, actually I couldn't continue the classes. Now today onwards it will be continued regular. Okay. So now here you check a letter is chosen at random from English alphabet. In English alphabet, how many letters are there? So that we know that 26 letters are there. So that means we can write so n of s equal to 26. Out of them, how many vowels are there? So let us have a discussion on vowels. How many vowels, such vowels exist in English alphabet? Vowels are A, E, I, O, U. So that means out of 26 there are 5 vowels. So obviously you are correct. 5 upon 26. So n of E equals to 5. So P of E equals to n of E upon n of S. So that is 5 upon 26. So what is the right answer now? Yes, C is the right option. C is the right option. (31) 31st question. The same question similar to the 30th question itself only. So let's have a discussion on that one also. A letter is chosen from the word congratulations. 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 Okay, S is also capital. The probability that it is a vowel. It is a vowel. Is. Okay. So let us do this problem now. Let me write the options first. A. 2 upon 5. B. 1 upon 2. C. 1 upon 4. D. 1 upon 5. A letter is chosen or selected from the word congratulations. Now I ask you one question. How many total number of letters are there present in the letter word the congratulations? Just you count it now. So that need to be treated as our total outcomes. N of S. N of S is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Am I correct? You can check it now. Out of them, how many vowels are there? Let us say E. Vowels. What are the vowels are there? Here O. Yes, O write down. And next A. Yes, A write down. Next we have U. U write down. We have A write down. Next I write down. O write down. That's all. So now we need to write N of E. Just count them. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4. So 1, 2, 3. 1 O A U A I O. 1, 2, 3, 4, 5, 6. Yes. So now P of E. N of E upon N of S. 6 upon 15. So that means 3 2 ja, 3 5 ja. 2 upon 5 is the right option. Obviously A is the right option. Yes, absolutely correct. Absolutely correct. Second question. 30-second. A card is drawn from a well shuffled deck of cards, deck of playing cards. Playing cards. The probability of drawing a block face card is. So this problem is related to the pack of cards or deck of playing cards. So option A is 1 upon 26. Option B 3 upon 26. Option C is 1 upon 52. Option D 3 upon 52. 3 upon 52. Okay, not actually the problems that will be level 2 or level 3 I will discuss, Amini. So that are available in EAMCET section. You can go through them. So most of the critical problems has been already discussed. A card is drawn from a well shuffled deck of playing cards. The total number of cards that are present in the playing cards, you know, that is 52. N of S is equal to 52. So that we can write N of S is equal to 52. So let's now the probability of drawing a block face card. How many face cards are there? In which out of them how many block face cards? So total actually king, queen, jack. They are face cards. Face cards. Total there are actually here 4 sets, 4 shoots, 4 into 3, 12. Out of 12 you divide by 2, that will be 6. 6 are black. 6 are red equally. 6 black. So that means now we can write n of e equals to 6. So Jyoti, welcome. P of e equals to n of e upon n of s. 6 upon 52. So now 2 3 ja, 2 2 ja 4, 12, 2 6 ja. 3 upon 26. 3 upon 26. So B is the right option. B is the right option. So 33. The probability that a number selected from the number numbers 1 2 3 and so on 15 is a multiple of 5 is A 1 upon 3, B 2 upon 3, C 1 upon 2, D 1 upon 5. So these questions are also very important regarding to the competitive corner or entrance, competitive entrance. The probability that a number selected from the numbers 1 to 15. So that means there are 15 numbers, total numbers. Out of them, we need to select multiple of 5. The probability that it should be a multiple of 5. First, let us write the multiples of 5. Multiples of 5. Multiples of 5. From only up to range 15 itself only. So multiples of 5 are 5 1 ja 5, 5 2 ja 10, 5 3 ja 15. So there are 3 such multiples. So that means actually you can write now. First let me write n of s, that is 15 obviously. N of e, it should be multiple of number of multiples of 5 in between 1 to 15. There are 3. So P of e equals to n of e upon n of s. 3 upon 15. 3 1 ja, 3 5 ja. So 1 upon 5 is the answer. Yes, D is the right option. Yes, option D. Okay, 34th problem. 34th problem. This is somewhat typical problem, level 2 problem. The probability of getting the probability of getting 53 Sundays 53 Sundays in an ordinary year, not leap year, non-leap year. That means ordinary year is, okay, Amini, first option is 1 upon 7, B is 2 upon 7, C 1 upon 365, D is 1 upon 366. So one of the problems, let me do very clearly, because it's based on the concept problem. After that we can create the shortcut also, so we can follow super trick. Even 53 Sundays or 52 Sundays in a leap year and a non-leap year, and we can have the discussion. So first let me explain the problem in a neat manner, in an elaborate manner. So first let me write like this. So first you check whether it is a leap year or non-leap year. Yes, ordinary year means non-leap year. So there are 365 days in a non-leap year. This first we should have to keep in mind. This is the important point. How many number of days in a non-leap year? First you divide 365 by 7 in order to find out total number of weeks in that particular year. 7 5 ja 35, so 15, 7 2 ja 14. So what that means, there are 52 complete weeks and remains one day. That means definitely in that year 52 Sundays will be there, but in order to be 53, this 53 must be depend on this one itself. This is important, very important. You remember this one. So now we can write, there are 52 Sundays and leaves a day. This day is very important. What are the possible for day? That we need to write it. So possible means, let us write S is equal to, it may be Sunday, it may be Monday, it may be Tuesday, it may be Wednesday, it may be Thursday, it may be Friday, or it may be Saturday. So one thing, already 52 Sundays are there. In order to be 53, the remaining day must be Sunday. If it is Sunday, then only there will be 53 Sundays possible. So that means now E equals to, you get like this, yes. So one possibility is there out of yes. 1 by 7 is the required probability. So that means P of getting 53 Sundays. 53 Sundays equals to n of E upon n of S. N of E is 1. N of S is 1, 2, 3, 4, 5, 6, 7. So this is the answer. 1 upon 7. Yes. 52 Sundays means there will be, it should not be Sunday. It should not be Sunday means it may be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. 6 chances are there. So that means I will give that note also. Very important note. So note. Instead of 53 Sundays, for example, you are asked 52 Sundays only. 52 Sundays means the remaining day should not be Sunday. That we can write 1 minus P of getting 53 Sundays. 1 minus 1 upon 7. This will be 6 upon 7. Not only Sunday, any day, either Monday or Tuesday, any problem is, you can write without paper, pen. You can, 53 means 1 by 7 in a non-leap year. 52 means you can remember 6 by 7. That's all. 53, you just check in a non-leap year, 1 upon 7. 52, 6 by 7. You remember like this. A is the right option. 35 question. A bag contains 30 balls, identical balls. You treat identical balls, 30 balls in total or in all, out of which some are red, balls, and remaining are green balls. If one ball is drawn at random sorry, 1 minute. 1 minute. A bag contains 30 balls in all, out of which some are red balls and remaining are green balls. Okay. If one ball is drawn from the bag and the probability that it is a red ball is 2/3. Podduru, Chenchupalli. Red ball is 2/3. Then number of green balls in a bag is. This is the question. Pranav Reddy. Conditional probability is actually we have conditional event we shall discuss in intermediate level. Okay, here we don't have any conditional probability. A is 10, B 20, C 30, D 15. Okay. So total there are 30 balls in a bag. Out of some are red balls. We do not know how many number of red balls are there. Say that is X. The remaining balls. Remaining are green balls. Green balls means 30 minus X. If one ball is drawn at random the probability that red ball we need to find out, that is equated to 2 by 3. After that you can find out x, the green balls we can find out. Okay, let us do it now. Solution. Let the number of red balls equal to x. Obviously green balls, number of green balls total 30, 30 minus x. Probability given, probability of green equal to 2 by 3. So that implies probability of green means favorable cases 30 minus x upon total is 30 equal to 2 upon 3. 3 1 ja, 3 10 ja. Cross multiplication. So that implies 30 minus x equal to 20. So x equal to 30 minus 20. 10. That means red ball is equal to 10. We need green balls. Green balls. Therefore, green balls is equal to, that is 30 minus x. So 30 minus 10. Obviously 20 only. Directly here also we can write. That is 20. Right? We need to find out 30 minus x itself only. So B is the right option. So we shall continue in the next session. Thank you. Bye bye. See you. Right. So it will be continued tomorrow also, this probability. Right. Still at least 10 more problems we need to complete it. Right.